Welcome to week one, lesson one, zero and negative exponents. So this week, or this lesson, I want you to be able to simplify expressions with an exponent of zero and with negative exponents. So first thing we want to make sure we understand is the invisible numbers. X equals X, we all know that. But with these X's, there are invisible ones there. So the coefficient or the number in front of X is a one if nothing's written. You knew this. Just wanted to make sure you remember it. If there's no exponent written, so like you can see on the X on the left, there's no exponent there. That's an exponent of one. It's not a zero, it's a one. Okay, so we want to make sure we understand that. Now, here's some examples of exponential expressions. Simplify -4 squared. And example 2 is -4 in parentheses squared. Okay, you'll find if you type that in the calculator, -4 squared without parentheses is -16. Whereas -4 squared in parentheses is +16. So what's the difference? The difference is in the different pieces. So let's take a look. The base. The base of this first one is the 4. The exponent is the 2. And the coefficient is the -1. It's the number in front of 4. Okay, there's no parentheses holding the negative and the 4 together. Therefore, the 4 is the base, and the -1 is the coefficient. Whereas in example 2, the base is the -4 because it's held together by the parentheses. The exponent is 2, and the coefficient is none, or you could say there's a 1 there in front of it. Okay, but for right now, we're going to say none. So make sure you see the difference between the base of 4 and the base of -4. It affects the answer at times. All right. Exponents on the calculator, you should know how to do this. If you don't, watch how I do this here. Enter the base of 8 in your calculator. So just type 8. Press the caret symbol. Now on the calculator, if you have a calculator that looks like this, it's on the left-hand side, and it looks like a little arrow pointing up. Okay. Enter the power of 4. So again, you just put 4, so it should look like 8 caret 4. Hit enter, and you should come up with 4,096. Try that now. All right, so we're going to take a look at some expanded forms of exponents. Expand 3 to the third, 3 squared, 3 to the first. What pattern do you see? Well, 3 to the third is 3 times 3 times 3, which equals 27. 3 squared is 3 times 3, which is 9. And 3 to the first is just 3, which is 3. What pattern do you see? Well, there's 1 less 3 each time, right? And what does that do to the answer? Well, it divides by 3. 27 divided by 3 because you're taking away a 3. 9 divided by 3. Now, what's 3 to the 0 power? A lot of people are going to say 0. Well, if you keep the pattern going of dividing by 3, what's 3 divided by 3? 3 divided by 3 is 1. There's nothing here, so there's no 3's left, but that doesn't mean we have 0. That means we have the number 1. It's an invisible 1. Okay? So that leads us to the first idea of zero exponents. Okay? We could keep this pattern going, right? So if 3 to the 0 is 1, and I keep dividing by 3, as the exponent drops by 1, I divide by 3 again. 1 divided by 3 is a fraction. It's 1/3. Divide by 3 again. I get 1 divided by 3 divided by 3, which is 1/9. Right? And we'll take a look at more in depth these ideas as we go in this video. Okay? So 0 as an exponent. For all bases, a is a base, where a cannot be 0. A to the 0 power is 1. So, a couple very quick examples. 5 to the 0 power, 1. 1.25 to the 0 power. You guessed it, 1. -2 to the 0 power. Yep, it's 1. 14/37 to the 0 power, 1. Now, the next one's a little tricky because that 6 is not inside the parentheses. The only thing that gets the 0 power is the 5. So 5 to the 0 power is 1, but then I didn't take that 1 and multiply it by 6, so I get 6 there. Pause it. Try this last one. okay? The only thing that gets the 0 power is x. So I have -3 times 1, x to the 0 power is 1, times 4. So -3 times 1 times 4 is -12. Okay. What is 0 to the 0 power? Don't really need to know this, but I thought I'd throw it in. It's actually undefined. It's not 1. It's one of the only ones, it's a tricky one. Don't really need to know it. Now let's move to negative exponents. For all bases, which we're going to call a again, a cannot be 0. A to the negative n equals 1 over a to the n. I use something called being happy. If a has a negative exponent, it's not happy being on the where it's at in the fraction. So right now, this a to the negative n is on top. It wants to go to the bottom. Once it goes to the bottom, it becomes happy or it has a positive exponent. We'll do a few examples. Oh, here's this as well. A to the negative n on the bottom, it's not happy on the bottom. It wants to go to the top. So basically, it moves in the fraction. So the base on this one is the 7. Is it happy? Well, its exponent is negative, so no, it's not. It wants to go to the top. Right now, it's on the bottom. So it moves to the top. The 7 doesn't change, but the exponent becomes positive. It becomes happy. And then 7 to the 3rd power, I can type that in the calculator, and I get 343. 4/5 to the negative 2nd. The negative exponent just means everything needs to switch where it's at. So the 5 goes to the top, and the 4 goes to the bottom. And now everything's happy. So that becomes 5 squared, which is 25, over 4 squared, which is 16. Okay, -5 to the -4th. -5 is in parentheses, so that is my base. It's not happy on the top, so it wants to go to the bottom. Once it goes to the bottom, the exponent becomes positive. Notice the base doesn't change. -5 stayed -5. Okay, so -5 to the 4th power is -5 times -5 times -5 times -5, which is positive 625 on the bottom. And there's a 1 left on top. On the last one, the only thing that's not happy is the y. Its exponent is negative, so it wants to go to the bottom. The 12 and the x are fine on top. The y goes to the bottom and becomes y to the first. We don't need to write the 1 because of the invisible 1 idea. If you want to put it there, it's okay, but 12x over y. Okay, last one we're going to look at is evaluate the expression for x equals -6 and y equals 9. So we're going to take -6 and plug it in for x, and we're going to take 9 and plug it in for y, but not yet. Okay, first thing we're going to do is we're going to simplify this expression first. Okay, so 4x to the -3rd, y squared. So the x is not happy on top. It wants to go to the bottom, like so. Now that everything has a positive exponent, I'm going to replace x and y with the numbers that we said to replace them with. So y gets replaced with 9. Make sure you use parentheses. And x gets replaced with -6. So 9 squared, we're going to do that first. We're doing order of operations here. So 9 squared is 81. 4 on top goes with it, so it's 4 times 81. -6 to the 3rd power. Again, type it in your calculator. You should get -216. Okay, -6 times -6 is positive. Times negative again, it makes it -216, so that negative on the bottom is okay. 4 times 81 is 324. The negative, I've shifted it out in front. Reduce that and reduce it again, and you get to -3/2. Okay, and that concludes our first lesson of week 1.